All right, so we're going to go through these answers. Number one, or the first one, really very easy, limit to infinity. We check, n squared is our biggest term, 4 over 1, so our answer is just 4. Just checking that top bigger, bottom bigger, or equal. And so in that case, they were equal. The next one says that this is continuous. So when we see that it is continuous, and then we see this x is not equal to 2, that's a big hint to take the limit right there. So when we take the limit, you're going to get 0 over 0. You can either factor, or you can do L'Hopital's. Either one will work. I'm going to factor. This is very easy to factor. Those cancel. When you plug in 2, 2 minus 2 goes to 0. But you also could have absolutely... Oh, wait. We're at negative 2. That's my fault. Negative 2 minus 2. Negative 2. Negative 2 for the x minus 2 goes to negative 4. You also could have done L'Hopital's rule. For L'Hopital's, you would have just done the limit as x approaches negative 2 and then taken the derivative 2x. And then on the bottom, the derivative is 1. Plug in negative 2. 2 times negative 2 is negative 4. So both of those ways work. All right, next one is an IVT question. So it says, if we know that f of negative 3 is 1 and f of 6 is 3, then IVT guarantees that. So we need a value in between x as negative 3 and 6, where the y value is in between negative 1 and 3. That's going to kind of be the answer. So f of 0 equals 0 could work, but it doesn't guarantee that that works, right? Because what it needs to guarantee is it guarantees that there is some f of c equal to 0 between x equals negative 3 and x equals 6. We don't know that that c value is 0. So that right there is what's telling me that that one doesn't work. B is f prime of c. That's wrong. That's probably an MVT. All right. And then c says negative 1 less than or equal to f of x less than or equal to 3 for all x. That's not true. That's saying that, basically the graph has to stay in between negative 1 and 3. But that's not true, right? It could go up above and come back down. So that's not true. And then C says f of c equals 1 for at least one value between negative 3 and 6. And E says f of c equals 0 for at least one c between negative 1 and 3. And so our choice is D. D is using our x values, right, in between negative 3 and 6. That's true. C is using the y values again, which doesn't make any sense. All right, next one, 28. We have a limit question. This one, if I plug in 0, I get e to the 0 is 1 minus 1 over tangent of 0. We need to memorize the 0 over 0, so we can do L'Hopital's. Now, I mentioned this on multiple choice. You do not need to show any work. You can just go ahead and do L'Hopital's. So you don't need they never check your work on multiple choice. So you can just redo it as a L'Hopital's rule. So this is chain rule, e to the 2x times 2. And then the derivative tangent is secant squared. If you've forgotten these, we're going to review these derivatives in upcoming videos. So it'll be 2e to the 0 over secant squared of 0. E to the 0 is just 1. And then secant squared is 1 over cosine of 0 squared. Well, cosine of 0 is just 1. 1 squared is 1. So this whole thing just is 2. Now, if this had been an FRQ, just making sure, on an FRQ, we know that what you would have had to also show is just write the limit as x approaches 0 of e to the 2x minus 1 is 0. You don't even have to show any work. And then below it, write the limit as x approaches 0 to the bottom of tangent of x equals 0. And then you can do the whole L'Hopital's thing. 37 is kind of a tricky one. So 37... if you plug this in, what you have to realize on 37 is that, if you ever get something weird with a cosecant or a secant, just try writing it as 1 over sine of x. Right? And so then we can write this a little bit nicer as x over sine x. And you might memorize this one as one of those like squeeze theorems that we memorize that just flipped, and our answer is 1. But if you don't, you can plug in 0. You get 0 over sine of 0 is 0. You can do L'Hopital's. And so when we do L'Hopital's, the derivative of the top of x is 1, and the derivative of the bottom sine is cosine. So it's 1 over cosine of 0. Cosine of 0 is 1. So our answer is 1. All right, 37 is a BC topic. And so honestly, I'm just going to say don't even worry about 37. If you really, really, really want to know how to do 37, you can go back to the video that I posted in December where I did do it. But 37, I was on a BC test. I'm going to skip it for right now so we can just be moving quickly. All right, 38, we're going to just plug in 0. So that's a direct substitution. So this is going to be 1 plus 0 to the 1 over 0th power. And this is in limits infinity. So this is basically 1 plus 0 to the infinity power. And, so that's basically, going out to infinity. But the problem is that, basically when you have 0 in the denominator, what you want to be thinking about is even though that limit approaches infinity, infinity wasn't a choice, so I could pick non-existent. But this is also a vertical asymptote. So our choices for vertical asymptotes are positive infinity, negative infinity, or DNE. And either way, our answer is going to be non-existent. Okay, so whenever you get that 0 in the denominator, remember that's a vertical asymptote in that spot. So infinity, negative infinity, or DNE. All right, next one. At x equals 3, the function given by f of x is, and they ask us, continuous, differentiable, all that good stuff. So in this case, we sort of have the 3 rules if it was an FRQ, but it's not an FRQ. So really all you have to do is just plug 3 into the top and the bottom and see if they're equal. So in the top, we get 9. And then the bottom, we get 18 minus 9, which is also 9. So on the top, that is telling me that this graph is continuous. So it is continuous because 3 squared is 9, and then 18 minus 9 right there. Now for the differentiable, we're going to do the same thing, but to the derivative. The derivative of x squared is 2x when x is less than 3. And then the derivative of 6x minus 9 is just 6 when x is greater than or equal to 3. So now we're going to do the same thing. I'm going to plug in there. So 2 times 3 is 6. And when we plug in anything to 6, it's still 6. So that's also differentiable. So this one would be both continuous and differentiable. Right, we plugged in 3, we got 9, and then 18 minus 9 is 9. Then we plugged into the derivative, we got 6 and 6. Now, how do we got 9 and 9, but here we have gotten like 6 and say 4? Then we would have chosen continuous but not differentiable. Had we gotten like 9 and 2, we would have chosen neither continuous nor differentiable. The undefined case would only apply if where you see this equals sign, you couldn't plug it in. That would be where it would occur. And then differentiable but not continuous, you can always cross this out. That's an impossible answer. That's impossible because if you remember, in order for a graph to be differentiable, it had to be continuous. All right, this one is a very old AP question, but it's kind of good practice. So it says, where is f not continuous? So we're kind of doing that same thing. We're going to plug in 0 here and here. So sine of 0 is 0, and 0 squared is 0. So, it is continuous at x equals 0. So it says, where is it not continuous? I'm going to cross out anything with a 0 in it. So now I'm actually just down to 1 and 2. Then let's plug in 1. So 1 squared is 1, and then 2 minus 1 is also 1. So I got 1 and 1. So it's actually also continuous at 1. So now I know my answer has to be C. But just to show it, when you plug in 2, 2 minus 2 is 0, and then 2 minus 3 is negative 1. So 0 and negative 1 are not equal, which is why it wasn't continuous at 2. All right, next one, they gave us if the limit as x approaches 3 of f of x equals 7, what must be true? And this one is a little bit interesting, but when they tell you a limit, all they're saying is that the y value approaches 7 as x approaches 3. They're not telling us anything about continuity or anything about differentiability or even anything about the f value. So this is actually none of them. Okay. If they had said the limit as x approaches 3 of f of x equals f of 3, that would be that, AF is continuous at x equals 3. And if it's continuous, then, F also, but it doesn't, if they said like, then that also equals 7, then I guess 3 would be true. But it doesn't tell us anything about differentiability. This is the definition of continuity. But it didn't say that. It gave us a number. So it doesn't tell us anything, right? Because this graph easily could be approaching 7 on both sides, but have a hole. So we don't know number 3, right? We don't know about number 1, and we don't know anything about differentiability. This next one's kind of tricky, but what we have to remember on this is actually kind of back at the top. I told you guys on page 1 or 2 when we were looking at these that a number to the x power is always bigger than x to a number power. So if x is in the exponent, it's always bigger. So when we're looking at this, limit to infinity, we're trying to figure out the top bigger or the bottom bigger, where the bottom's always going to be bigger here. So it doesn't matter what it is, this is bigger. So our answer, when the bottom is bigger, that limit is always 0. So it doesn't matter what k is. Next one, another limit to infinity, put a 1 here, 3 over 1, it's just 3. All right, next one we can do L'Hopital's rule, because if you plug in cosine, you get 1. So 1 minus 1, you plug in sine, you get 0. That's cosine, that's L'Hopital's rule. So then we do the limit as theta approaches 0. Now the derivative of negative cosine is positive sine, because it's, derivative of cosine is negative sine, so the two negatives go to positive. And then here, this one's a little bit hard, but you want to write this as 2, and then sine of theta squared. It's actually chain rule. So it becomes 4 sine of theta to the first power times chain rule cosine theta. So the sine thetas are going to cancel out. 1 over 4 times cosine of 0, because you're going to plug in the 0. So that's just 1/4. Kind of tricky. I think this was a BC question. I wouldn't really expect to see something like that. All right, next one. They give us, similar to that other one, they give us the limit as x approaches a is equal to L. The last one said 7, but it says L is a real number. You could just call it 7. And so then from here, right, it's kind of the same thing. Our answer is just none of the above. It doesn't actually tell us anything. It doesn't tell us that the derivative exists, that it's continuous, that it's even defined. It just doesn't really tell us anything. So the graph here is given. It says which statement is true. The limit as x approaches a is equal to the limit as x approaches b. The limit as x approaches a is 2. The limit as x approaches b is actually dne. So that's not true. The limit as x approaches a is 2. Yeah, we just said that was true. B we said was dne. And a we said was 2. So that choice is obviously B. All right, next one is up here. So we have the graph is shown and which statement is false. So f is continuous at a. That is false. F has a relative maximum at a. That's kind of weird, but I guess it is true because that's the value at a. So around it, the points are smaller. So it's kind of a weird one. But that's why, remember we said with our critical points, they're when f prime of x is equal to 0 or dne. Well, this would be a dne case, and this point's bigger, so that's why it's a maximum. Kind of a weird one, though. X equals a is in the domain. Yeah, it exists. The limit from the right and the left are equal. The limit exists. So yeah, the answer is obviously a is false. Okay. Next one is the limit as x approaches 1 of x over ln of x. Now, this is not L'Hopital's rule because when we plug in 1, we get 1 over ln of 1. And the ln of 1 you have to memorize as 0. With ln, you want to make sure that you memorize the ln of 1 is 0. The ln of 0 is dne. And the ln of e cancels out to 1. And you also kind of want to make sure you know the graph of ln, which looks like that. Right, so that's at 1, that's where it crosses the 0. So you need to know is that any ln of any number that's, that number is less than 1, those are negatives. And then after 1, these are all positives. So the ln of any number bigger than 1 is positive. So anyways, we get 1 over 0. Whenever we get this is the vertical asymptote case. And so that actually goes right into what I was just talking about with the positives and the negatives. So what we're going to realize is that, basically if you plug in a number smaller than 1, you do this limit as x approaches 1 from the left side, right? When you plug in, 0.9, you'll get a positive for 0.9. But then the ln of 0.9 is down here. It's in this negative area, right? So this is going to go to negative infinity. Then when we do the limit as x approaches 1 from the right side, 1.1 we have positive over here is positive. So that's positive infinity. So the limit is dne. Now, you actually didn't really even have to do any of that, because if you look at, as soon as you get 1 over 0, it's vertical asymptote. Your choices are infinity, negative infinity, or dne. Well, they don't have infinity or negative infinity. They just have non-existent, so it's non-existent. All right, next up, we have a limit e to the x minus 1 over 2x. Okay, we plug in 0. We get e to the 0 is 1 minus 1 over 0. 0 over 0, we can do L'Hopital's. So we're going to do L'Hopital's. Limit as x approaches 0 of e to the x over 2. All right, and so that's e to the 0 is 1 over 2. So we just get 1/2. All right, next one we have is another one of these limit questions, and it's the limit as x approaches 2. So basically you're just plugging in 2 to both of these and seeing if they're equal or not. So on the top we have ln of 2. On the bottom we have 2 squared is 4 ln of 2. Well, ln of 2 is not the same as 4 ln of 2, so our answer is non-existent. Then we have let g be continuous. Which of the following is not necessarily true? And so if g is continuous, they don't say continuous and differentiable, then MVT doesn't apply yet. So it doesn't matter if the rules for MVT work, it doesn't apply yet because we needed to see continuous and differentiable. The only one that applies is IVT. So they say which one is not necessarily true. So if we see anything with like a G prime, we'll get rid of it. But in this case, there aren't any. They're all, I think, talking about IVT. So the first one says there exists a number such that G of H is bigger than G of X. That's the extreme value theorem, which is actually also true for continuous. Then the next one says for all A and B, if A is equal to B, then G of A is equal to G of B. Well, that kind of makes sense. Like if this was 2 and that's 2, then G of 2 is the same as G of 2. That's kind of silly. The next one says that there's a number where we have G of H equal to 1/2. Well, 1/2 is between 0 and 1, so that's IVT. This one says equals to 3/2. Well, that's not in between 0 and 1, so that's not necessarily true. All right, after that, we have what positive values would make f continuous. So that's where, again, we're going to take that limit. We're going to take the limit. And in this case, it's a little bit tricky to know what to take the limit as we approach, but it's saying which ones. So I'm going to just take the limit of 1, 2, and 4. Right, and really, 1 and 4, because those are the ones that we see. So x approaches 1 of x minus 1 over x squared minus 4. Over in here, I can do x plus a and x minus a. But we're saying, that our a might be 1, right? We're saying that our a might be 1. So this would be x squared minus 1. So that becomes x minus 1 times x squared minus 4 over, we can change this to x plus 1 and x minus 1. Those cancel. When we plug in 1, 1 squared minus 4 is negative 3 over 2. That works. So 1 did work. And now let's try it with 4. So the limit as x approaches 4 of x minus 1 times x squared minus 4 over x squared minus 4. Well, these are going to cancel. 4 minus 1 is just 3. So that worked too. So 1 and 4 will both work. So it kind of makes sense because it allows us to factor out. When you plug in 1 or 4, it allows us to factor out. Okay, 2 doesn't work because if you try 2, you can't factor x squared minus 2. It's not a perfect square. All right, next one is pretty difficult and kind of either requires a very complex L'Hopital's rule with chain rule. So again, I'm going to not worry about this. You're not going to see something like this on our exam. I'm very confident about that. If you really want to review it, go back and look at the December video. All right, next one we have is another one of these limits to infinity. And what you can do is just look at the bigger terms. That becomes negative 2x squared and that becomes x squared. So our answer is -2. Okay, here's another L'Hopital's rule or factoring rule. If you do L'Hopital's rule, you're going to have to do a bunch of times on this one. So on this one, I kind of prefer factoring. So we get factor out an x squared, and we get 5x squared plus 8 over x squared times 3x squared minus 16. Those cancel, you plug in 0, and you just get 8 over -16, which is -1/2. You can do L'Hopital's rule, you can try it out. You would just have to do it like 2 or 3 times, because you do L'Hopital's rule, you get 0 over 0 again. Then you do L'Hopital's rule, you get 0, 0 again. Right, and then we have this next one, where we talked about this this morning. This is the limit side, and this is the f of 2 side. So it says which of these statements are true. So one says f has a limit. Well, if we do the limit as x approaches 2 of x squared minus 4 over x minus 2, you can do L'Hopital's rule, or you can factor. I'll factor. Whenever I see an easy factor, I just factor. But if you like L'Hopital's rule better, absolutely do it. Plug in 2, you get 4. So it does have a limit. Now, is it continuous? Well, this one was 4, this side is 1, so no, it's not continuous. As soon as it's not continuous, not differentiable. So it's just choice A. You don't even have to take the derivatives, right? It's not continuous, can't be differentiable. All right, next one, we have a graph. It says which of these are true. So the limit as it approaches the left exists, the right exists, but the overall limits are different, so it's just 1 and 2. Very easy. And next one, we have another kind of IVT, MVT type question. So it says the function is continuous. And then it says if there is no value c for which f prime of c equals 0, which statement must be true? Well, it only told us it's continuous. So this here, when we see the derivative, that's like an MVT question. So what we kind of need is if this isn't happening, if there's no c where that happens, then it wasn't differentiable. Right, because MVT needs it to be continuous and differentiable. So when you read through these, the one where it's not differentiable is that one, right? F prime doesn't exist. All right, and then next we have an asymptote question. So when we see the word asymptote, we want to really be thinking, that we have two kinds of asymptotes. We either have horizontal asymptotes, like y equals 2 is a horizontal asymptote. Or we have vertical asymptotes. And vertical asymptotes are, when we get a limit going up to infinity, something like this. Vertical asymptotes can deal with limits. This one I guess would be 2. Say like x squared over x minus 2 squared. This would be a vertical asymptote, and the limit on both sides would go to infinity. Now we'd have to do that. We talked about this in the class notes this morning, where you plug in a number like 1.9, you'd get positive. Well, first you plug in 2. The very first thing you always do is plug in 2 actually. So you plug in 2 and you get 4 over 0. As soon as I get 4 over 0, I know it's a vertical asymptote. So now I check, something like 2.1. Plug in 2.1, I get positive over positive, going to positive infinity. Plug in 1.9, positive over positive, going to positive infinity. And so that this limit would then be equal to positive infinity. Right, and so those do have to deal with limits at times. Horizontal asymptotes, right, these are actually the limits as x approaches infinity, and this is where we have those rules, which is bigger, the top or the bottom, right? So I actually I kind of forgot to talk about that in the notes, so it's good that we have a question on this to go over that. But these 3 rules here, and it does say it in the notes, I just don't think I actually said it out loud, is that anytime you get a limit going out to infinity, or you see the word horizontal asymptote, it's the same thing. It's those rules, those cases. So in this case, they don't say limit to infinity, but they do say that the horizontal line y equals 2 is an asymptote, right? Horizontal line y equals 2, both kind of things. So we know that that means that the limit as x approaches infinity of f of x is equal to 2. That's what this means. So it says which one of these is true? Well, that's choice E. Okay, so very nice and easy. We just basically are finding the limit that goes out to infinity, because that's the definition for horizontal. Okay, the next one is pretty much the same question, and they could have said this as a limit, or they could have said what is the horizontal asymptote of this. Now, cubed is our biggest, so that answer is just 1/4. Very easy. We have another one of these. This one says, which one of these values is continuous but not differentiable? I feel like I've given this question to you guys before on a test. So it's continuous at A because it's connected, but it's not differentiable because it's making that cusp, that corner. So this would be choice A. Right at B, it's not continuous. At C, it is continuous and it's differentiable. The derivative would be 0. At D, it's not continuous. It has a jump. And at E, it's both continuous and differentiable. C and E are both continuous and differentiable. All right, 20 gives us a piecewise function. And so when we see a piecewise function here, the first thing that you might want to do is just plug in 3. So 3 plus 2 is 5. 4 times 3 is 12. 12 minus 7 is also 5. So this means that the limit exists and that it's continuous because both sides were equal to each other. Now for differentiable, we're going to need to take the derivatives. The derivative of x plus 2 is 1. When x is less than or equal to 3, the derivative of 4x minus 7 is 4. When x is greater than 3, if we plug in 3 to both of these, 1 and 4 are not equal, so it's not differentiable. This would be 1 and 2 only. And that's it for the non-calc questions. Now we're on to calculator questions. Now with limits, honestly, the calculator questions are just the same thing, but they're just maybe calculator questions that take a little bit longer, but you don't actually use a calculator most of the time. So they're just basically giving you an extra minute because on the calculator side, you have 3 minutes per question. The non-calculator side, you have 2 minutes. So they're just saying these questions might take them a little bit longer to think about and analyze. So it says, which of these does the limit as x approaches 4 exist? Well, this one, it does exist. It's not continuous, but the limit exists. This one, same thing. It's not continuous, but the limit exists. In this one, the limit does not exist because there's a jump. So this would be 1 and 2 only. Right. And then now we have some free response stuff. So it says show that f is continuous at x equals 0. And so when we see continuous on free response, this is where we have to do those 3 rules. So first rule is that f of 0 exists. So I'm going to use where the equals part was. So this is going to be 1 minus 2 sine of 0. Well, I know that sine of 0 is 0. This is 1 minus 0, which is just 1. So you'd say f of 0 exists. And then secondly, we're going to check that the limit as x approaches 0 of f of x, we want to make sure that that exists. So in order to do that, we need to do the left and the right side limits. So first I'm going to do the limit as x approaches 0 on the left of f of x. Now this is going to be the left is going to be whatever side is smaller than 0. Well, smaller than 0 is a less than sign. So that's the 1 minus 2 sine of 0 thing, which we just basically did. So we just did this, so we got 1. Now let's do the same thing with our right side limit. Right, so this is going to be, basically the right side is going to be the greater than side, so e to the negative 4 times 0. 4 times 0 is just 0, and anything to 0 is 1. So what we can say is that, the limit as x approaches 0 from the left side of f of x equals, I'm going to put equals 1, which equals the limit as x approaches 0 from the right side of f of x. But if you didn't put the 1 in the middle, that would be fine. You could just say the left side equals the right side. But we definitely want to say that the left side equals the right side. We want to write that out. Because that is true, then therefore the limit as x approaches 0 of f of x must equal 1 because it's, the left and the right were both 1, so the overall is 1. Right, so that one also exists. And then our third rule is, are those the same? So f of 0 is 1. And the limit as x approaches 0 of f of x was 1. So basically what we're saying now is that f of 0 equals the limit as x approaches 0 of f of x. So because all 3 of these are true, then therefore f of x is continuous at x equals 1. Right, so we're just kind of showing all 3 rules. Now, this guy's the exact same, except it's just with a calculator. So basically, we're going to apply the same 3 rules, but now we just have to use a calculator in order to do it. So our first thing is that we're going to do R of 5. Okay, R of 5 is going to be where we see the equals with the 5. So I did on my calculator 600t over t plus 3 at time 5. I got 375. So R of 5 does exist. Then the second thing is, does our limit exist? So I'm going to do the limit as x approaches 5 from the left side of R of t. Or we write R of t, not R of 5 anymore because the 5 is there. Now less than is the left side of 5. Greater than is the right side of 5. We just have to know that. So less than, we already did this. It was 375. So now we're going to do the greater than side. You can either do R of t, or you can even write, the 1000 e to the negative 0.2t. So we'll do that on our calculator. And we get 367.8794. So we'll write that in. And we don't have to really show the third step. What we're going to show here is that because of these two, the limit as x approaches 5, I want to write from the left side of f of x, or r, not f of x, but r of t, does not equal the limit as x approaches 5 from the right side of r of t, because that line here, that's why that the limit as x approaches 5 of r of t, the overall limit, does not exist. Right? So then we can kind of say, therefore, r is not continuous at time 5. And with the therefore, we're saying because of all this. But if you want to, you could also, not have the therefore. It might be a little bit more clear to say r is not continuous at time 5 because the limit as x approaches 5 of r of t does not exist. That was our reason why the limit didn't exist. So that's it for this. Like I said, one thing just to watch out for is those L'Hopital's questions. And so even though this wasn't part of the packet, I did want to add this question in here. Just, part D of this question. This was from the 2018 exam. So it gave us f of x is this function here. And it said, hey, let g of x be a differentiable function where g of pi over 2 is 0. And then the graph of g prime is shown below. So they said find the value of the limit. And like I said this in class, is whenever you get a limit with a fraction, there's a very, very likely chance that it's L'Hopital's rule. But we do need to show that. So when we plug in pi over 2, well, to the top, that's going to be e to the pi over 2 times cosine of pi over 2. Over, and then g of pi over 2 they gave us was 0. Now, cosine of pi over 2, we need these memorized, is 0, 1, so it's the 0. So cosine of pi over 2 is 0. So e to the pi over 2 times 0 is 0 over 0. Now, this is what I do to now know, hey, I'm doing L'Hopital's rule. But what I told you in class that we have to write down is you absolutely have to write the limit as x approaches pi over 2 of the top, which is just f of x, equals 0. And then the limit as x approaches pi over 2 of the bottom is 0. And so then we can kind of say L'Hopital's applies. Just do those 3 bullet points and you'll make sure that you get full credit. Then now that we've shown that L'Hopital's will apply, now we can do L'Hopital's. So L'Hopital's is to then take the derivative of the top, which would be f prime of x, over the derivative of the bottom, which would be g prime of x. Now, f prime of x, we do need to actually show that work because it's a function. So this is product rule. Okay? And within this question, you may have already done it. I'm not sure if we did it. I kind of forget. But it's product rule. So the derivative of the first is e to the x. We're going to leave cosine of x alone. And then the derivative of the second, we leave e to the x alone. And the derivative of cosine of x is negative sine of x. And then the derivative of the bottom will just stay g prime of x because it's a graph. So now let's plug in pi over 2 everywhere. So e to the pi over 2 times we already established that cosine of pi over 2 is 0. And then plus e to the pi over 2. Now this time, times negative, now sine of pi over 2, right, is the 1. So times negative 1. All over. Now for g prime, they gave us the graph of g prime. Be very careful. This is the graph of g prime, not of g. So normally, when we see prime, we're thinking slope. But this already is g prime. Right? They're already giving us g prime. So we don't need to do the slope. We're just getting the y value. So the y values are g prime values. So at pi over 2, we're at 2. So this becomes, that goes to 0, negative e to the pi over 2 over 2, and that is our answer. So that's a pretty good L'Hopital's rule question to kind of review and look at, is this one here. So that is it for our homework. Watching this video, just putting down your answers as the homework, just go ahead and turn in a PDF of those answers that you kind of copied down as you watch the video. And let me know if any of these were confusing. Just send me an email. Let me know in class if any of these confused you and you want me to review them with you one more time.